in terms of speed, but also in terms of power loss. When we take a look at this chart, when we have the conventional bearing without any cooling or direct cooling, the temperature is around 160 degrees with 35 kilowatts. But what do we have to do to reduce the oil that is needed? In this case, it's 15 liters per minute. Let's say by approximately half. In this case, it would be 8 liters per minute. By just adding a little bit through the helical cooling channel. And in this case, we were saving roughly 50% of oil supplied, and also reduce the power loss of the bearing from 35 to 29 kilowatts. That's only the small machine element, but what effect does it have on the aircraft engine? A huge effect, as you can see here, because if you can build up a bearing that needs less oil, the whole oil system can be designed much smaller. The oil pumps, the oil kerosene cooler, the oil air cooler, the scavenge lines, the accessory gearbox, everything like that. And so we can save already in the oil system 16 kilowatts and 16 kilogram of mass, and therefore reducing the kerosene consumption for one engine per year by 30 tons of kerosene. And you can imagine for a bigger fleet, that's a good amount of power loss and kerosene that you are saving. And maybe last few words on electric systems. Now we were talking a little bit about components and how they influence the reduction of power losses and emissions. But if we want to go to net zero, we have to find a solution, either SAF or electric systems or fuel cells or things like that. And since Schaeffler is delivering for a couple of years now complete systems into the automotive industry, complete electric systems, starting with power electronics, gearboxes, but in the last recent years also complete e-axle systems that are plug and play in the passenger car with the power electronics, with the gearboxes and the electric motors. And that is also being currently transferred into the aerospace industry. And this is a good example that we developed over the last 5 years. It's a double redundant electric motor transferred from the automotive industry into the aerospace industry. With 300 kilowatts, at takeoff, it powered a Pipistrel aircraft and was flight tested last year and the year before on a Pipistrel for fuel cells and full electric battery technology. And this is a super good example how we can transfer technology into the aerospace industry. And coming to the last and final slide, so we see we need to have system understanding, but of course also understanding of the small mechanical component, because everything influences each other. So coming from manufacturing processes like welding, milling, drilling, up to a complete electric system will be the key in the future also for net zero or significant emission reduction technologies. Thank you very much for your attention, and I will hand over to the next speaker.
Yeah.
Thank you.